We have a integral here, definite integral, and it's going to involve some u substitution. If I let u equal 1 over x squared, well, that doesn't do anything for me. And usually we look for the composition, and we have cosine squared of 1 over x, and notice if I take the derivative of 1 over x, I get negative 1 over x squared, so that's a good candidate to try and see. So let u equal 1 over x, see if it works out for us. So we'll let u equal 1 over x, and then du equals negative 1 over x squared dx. And the only thing, I have a 1 over x squared dx in my integral. I have a negative 1 over x squared dx equals du. So negative du equals 1 over x squared dx. Now I can make my substitution. I'll bring that negative out front, and 1 over x squared dx is negative du, so that will be du, and then u is equal to 1 over x, so I'm left with the cosine squared. Oh, why am I writing a 4? 1 over x. That doesn't look very good, does it? Let's change that. Just erase all this junk. Sorry, it took me a little time. Okay, that's just the cosine squared of u du. Now, this book, a lot of times in Cal 2, the second they tell you how to do even power, integrate even powers of the cosine, but it's in this textbook, and it's fairly early in the problem set too. So, what you need to do here is you need to use an identity, and the identity is based on one of the double angle formulas of the cosine, or the identity for the double angle, and you have the cosine of 2 theta, one of them anyway, is 2 cosine squared of theta minus 1. And if I solve for cosine squared, because notice that's what I have right here, then I would get cosine squared of theta. Remember, if I added 1 to both sides and then divided by 2, I would get 1 plus, writing off the little page, the cosine of 2 theta over 2. So I can substitute in for cosine squared of u, 1 plus cosine of 2u over 2. 1 plus the cosine of 2u over 2. And now I can just break this up into 1 over 2 plus 1 over 2 times the cosine of 2u. So we have negative times 1 over 2 plus 1 over 2 cosine of 2u du. Now I can integrate, and I have minus times the integral with respect to u, 1/2 is 1/2 u. The integral of 1/2 cosine of 2u, well, the 1/2 is a constant, and then the integral of the cosine of 2u, the function whose derivative is the cosine of 2u, is 1 over 2 sine of 2u. And we'll do that plus c. Trying to decide whether I really even care about distributing that negative. Well, let's just distribute that negative and sub back in for u as we go. So we get negative 1 over 2 times u is 1 over x. You can tell I don't still want to skip that step, but I was going to put that x right there. Minus 1 over 4 times the sine of 2 over x plus c. I'll just clean that up a bit. We get negative 1 over 2x minus 1 over 4 sine of 2 over x. Oops. Plus c. And that's it.